Okay, so class 9, chapter 9, force and laws of motion. We will do today question 9 to 13 on your tuition note. Go to your tuition note, open your tuition note to page 110. These are just, I think we can just read through it also, we'll get it now. Because in the previous class we have discussed what is inertia and the first law of motion. Let me read the question, question number 9. Write two more examples of inertia. Okay, first, when the card, write two more examples of inertia. Okay, so when the card is flicked with the finger, the coin placed over it falls into the glass. So this is the cup. There's a paper over it, you put a coin and then you flip the paper. The coin doesn't go with the paper, but it falls into the cup. Nah? That's what it is saying. Even as the card shoots away as shown in the figure, as you can see in the figure, the coin is there and the card is there. You pull it or push it very fast, the paper will flip away, but the coin falls to into the cup. Okay, so this is why we're going to see. This is because the coin tends to, before you flip the paper, the coin was at rest, not moving. So the first law of motion, inertia, says since it's in rest, the tendency of the coin object is to continue in that state of rest. Even when you move the paper, it likes to continue in rest. Because of that, it did not move with the paper, fell into the cup. This is because the coin tends to continue in its state of rest even when the card shoots away due to its inertia of rest, right? B, first example, B, second example. When a water or tea-filled cup, these are all common examples, so you will get it. When a water or tea-filled cup on a tray is turned around swiftly, the cup topples. When a water or tea-filled cup on a tray is turned around swiftly, the cup topples and the liquid spills. This is because the cup or liquid tends to continue in its state of rest due to its inertia, even when the tray is turned around. To avoid this, grooves are provided in saucers for placing teacups. So in the tray you put and you move the tray quickly, then the cup continues in rest and spills the tea inside it. So to avoid that inertia of rest of the cup not moving with the tray, saucers, these small trays are provided with grooves, means small holes where the bottom of the cup will fix, so that when the saucer moves, the teacup also will move along with it instead of continuing in rest. Okay. Why are grooves provided in saucers to place teacups? The answer to that is there. Question number 10. Heavier or more massive objects offer more inertia, larger inertia. Proof with an example. You can just understand by reading through it. We know that it is easier to push empty box than a box full of books. Agree with that, right? So if there is empty box, it's easier to push or pull. If it's full of books, it's difficult to push. Heavier. Similarly, it is easier to kick away a football than a stone of the same size. There's a stone of same size and a football, then of course nobody will kick the stone because it's too heavy. It will hurt your leg. The inertia is too high, the inertia of rest. Because inertia is too high because of the mass of the stone. But the football of the same size, very easy to kick away because it's lighter. Also, it is easier to flick away the card on which is placed 1 over a glass tumbler than 1 rupee coin than a 5 rupee coin. That means if you put a 1 rupee coin and put a paper coin over the cup, it's easier to pull the paper away for the 1 rupee coin. Then if you put a 5 rupee coin, it's more difficult because 5 rupees is heavier, right? So also a force that is just enough to cause a small card to pick up a large velocity, a force that may be able to push a cart to a fast speed, will not even move the train at all. The same force that is moving a cart very fast, if you apply the same force on a heavy train, also the train will not move at all. Reason is it's too heavy, right? All these examples in daily life therefore prove that heavier or more massive objects like train and all offer more inertia. That's why they are not moving, right? Now go to the next question, question number 11. This is textbook question also. You can open your textbook also. Question number 1, page 126 on your textbook. Tuition note is page 111. Okay. Textbook is 126. Which of the following has more inertia and why? Rubber ball and a stone of the same size. B, bicycle or a train. C, 5 rupee coin or 1 rupee coin. Answer A. Since the stone is heavier, it has more inertia than the rubber ball of the same size. B, since the train is heavier, it has more inertia than the bicycle. C, Since the 5 rupee coin is heavier, it has more inertia than the 1 rupee coin. This is like repetition of what we discussed just now. So let's go on. Question number 12 on tuition note. This is question number 3. What is question 12 on tuition note, page 111? Is question 3 on textbook 126. Okay, I'll just read the answer for us. Even if we vigorously shake the branch, the question is saying, when we go and shake a tree like this, the leaf falls. Why? The question is saying like that. So let us answer it. Even if we vigorously shake the branch, the leaves tend to continue in its previous state of rest due to their inertia of rest, causing a tendency for the leaves to get detached. So because before you shook the tree, the leaves were at rest. So when you suddenly shake it violently, then a great speed is applied. The tree moves, but the leaves which were at rest like to continue in rest because of the first law of motion. So because of its unwillingness to move along with the moving tree, it gets detached from the tree and the leaves fall down. Thus, some leaves may get detached and fall down to the ground. Okay, 13, the last question in this class. This is 13 on page 113 of question number 13 on tuition note of page 113. On textbook, it is question 4, page 126. Let me read it. When I'm moving, answer only, I'm reading it. When a moving bus brakes to stop, the lower part of our body stops with the bus. When we're sitting on the bus stops. The lower part of our body also stops with the bus. But the upper part was moving with the bus. So when the bus stops, the upper part continues to move because of its previous motion with the bus. So because of that, our upper part of the body falls forward, right? Tend to continue in its previous state of motion due to inertia, causing a tendency to fall forward when the bus applies the brake. So thus we fall forward. So the question is saying, why do we fall forward when the bus applies the brake? It's because of the inertia of motion that we were going through with the bus. So when the bus suddenly apply brake, our lower part of the body stop with the bus, but the upper part continue in its previous motion, therefore it's falling forward. Similarly, when the bus suddenly from stoppage, it suddenly pick up speed, then our lower part of the body was at rest with the bus which was at rest, but the sudden movement of the bus along with the lower part of our body moves, but the upper part is in its inertia previous state of rest, therefore it begins to fall backward. So when bus suddenly start, we fall backward because of that, right? So similarly, when the bus accelerates from rest, the lower part of our body accelerates with the bus, but the upper part of our body tends to continue in its previous state of rest due to inertia of rest, causing a tendency to fall backwards when the bus suddenly picks up speed. Okay, so these are the questions, simple ones from 9 to 13. We will continue with a new topic in the next class, that is momentum. Okay, so that'll be enough for today. Okay.